Hello and welcome back to the second lesson in the third chapter of differentiation. In this lesson, we will learn about the derivative. We will begin the chapter by looking at the learning objectives. We will find derivative of a function at a given point, sketching the graph of function using its derivative, understanding relationship between continuity and differentiability, study differentiability of function at a given point, and estimate the derivative of given point using tables. We will look into all of these objectives or similar type of problems. We have about 9 problems. Two problems each might cover each of the objectives. So when we solve the problems, you'll come across these. The keywords are differentiability, continuity, vertical tangent, cusp, corner. Now, we will come across these words as well in the lesson, so stay tuned for these words. Now we will begin with the first topic, derivative. So we saw in the last lesson that we use this formula. Now, what's great about this formula? This is a limits formula where we told that h, where 2 points are considered for the first tangent. We solve tangent. The distance between the 2 points is it's approaching 0. That means it's identically the same point, and then we get the tangent easily. So that was about it. And even for the velocity, for instantaneous, at a particular instant, we told the times between two distances. We need at a particular time. So as the time approaches 0, we got the same thing. Same formula was used for both. So now the speciality of this is basically we can relate to unrelatable stuff. So velocity and tangent, which is not related, is related by this formula. So now we call this generally as derivative. Okay, so now over here, at any point x equals, it is given like 1, 2, 3, at any time of instant, we solved at different points, or at any x value, we can use this. Now, if the limit exists, we call it differentiable. Like in the sense, if there is answers, the left side and right side, when we do it for both the sides, if the limit exists, then it is differentiable at that point. Now let us see what is about the problem. We will solve this problem and then we can continue more about it. So here we have compute the derivative of f of x equals this particular function at x equals 1. First, let's recall the formula. This was the formula f dash of 1. Now over here we are dealing with 1 because x is given as 1. This a over here, it would have been f of a plus h minus f of a divided by h. This is the exact formula, but here, since a is given as the 1 value, whatever is told x value, we put it over here. And now what do? We need to substitute this instead of this given function. Instead of x, we have to put 1 plus h. So let's solve this here. So here, when we substitute it, what's going to happen? The first term is going to be 3. Instead of x, we have 1 plus h the whole cube plus 2 multiplied by 1 plus h. And lastly, we have minus 1. This is the first term. All we did is, instead of x, we have 1 plus h, function of 1 plus h. So wherever x is there, we put 1 plus h. So instead of x, we have 1 plus h whole cube and so on. Now this entire term minus, what do we have over here? F of 1, because it's 1. Now over here, wherever x is there, you have to put 1. So 1 cube will be 1, so I'm not going to write that. 2 times 1, it will be 2. And over here, this is a divided by h. Now we have to simplify. I hope you remember the a1 plus h the whole cube formula. It is a cube plus b cube plus 3ab plus 3ab. You can square one of each. It will be a squared once and b squared once. This is the expansion. Or if you're getting confused, what you can do is, this is a plus b the whole square multiplied by a plus b. You can do the a plus b the whole square formula and then do distributed property for 1 plus h term. But this formula is much easier because the other one will be very complicated. So now let's just substitute. And also a quick reminder, here limit is there. Always remember to write this. Now you can do this entire thing in calculator. Just type this in and equate it near to 0.001 and 0. minus 0.001. You're going to get the answer directly. But anyways, let's do the method. And that's going to be 3 multiplied by 1 cube is 1 plus h cube plus 3 times a square is 1 into h, 3h, plus this is going to be 3 into h square, 3h square. Okay, now what's remaining? It's plus 2 times 1 is 2 plus 2h minus 1 minus 3 plus 2 is 5 minus 1 is 4. I'm just solving it. It's divided by h. It's always there. I'm not going to write it again and again. Let me just simplify the numerator. Over here, I'll directly simplify it down. Remember, this still remains. I'm just doing the simplification of this only. It's going to be, here you can't simplify. Let's multiply the 3 inside. It'll be 3 plus 3h cube plus 9h plus 9h square plus 2 minus 1 is 1. So I'm going to solve this directly. 2 minus 1 is 1 plus 2h, and there is minus 4. So let us simplify the biggest term. It is just 3h cube. Next we have plus 9h square plus 9h plus 2h will be 11h plus the numbers 3 plus 1 is 4 minus 4 will be 0, so I'm not going to write it. So this is the simplification, and we have divided by h. So what happens is you can take h common out, isn't it? You can remove h common out. So if you remove h outside, it will be 3h square plus 9h plus 11 divided by h, which cancels out. And now you can substitute the limit. Don't forget the limit. Substitute the limit. Over here it will be 3 into 0 square plus 9 into 0 plus 11. The answer is 11. So this is the limit. Let's double check it in the calculator. So what I'm doing is I'll have to just substitute this over here. 3 multiplied by 1 plus h is a variable, so I'll use x cube in this case. Yeah, correct. 3 into 1 plus h cube plus 2 multiplied with 1 plus h, that is x, close the bracket, minus 1, and this entire thing will be subtracted by, this entire term is subtracted by 3 plus 2 minus 1 is 4. So I'll just write 4 over here, divided by h is x. Now you need to calculate near 0.001. You're getting 11.009, which is almost the 11. And also do it for the other side, left side, is negative 0.001. Negative 0.001 would give us again 10.99, which is almost 11. Both limits are coming towards the same value of 11. So this is the answer. Or you can do it by this method. It's the same. And over here we are getting answer is 11. So at x equals 1, the derivative using this formula is this. Don't worry. In the next chapter, in the coming chapter, this can be easily solved. If you know the derivatives, the power always comes down. It's going to be 3 times 3. It's 9x, and it reduces by 1 plus 2. That's it. And now you substitute this over here. It will be 9 times 1 plus 2. So the answer is 11. So entire thing can be simplified just in 2 steps using differentiations, derivatives, using the power rule and everything. This is not yet done. We will do it in the next chapters. So if you're finding this very difficult, if you cannot understand, wrap your head around this, don't worry. This calculator method, even if that's confusing, there is coming chapters which will make this very, very easy. But for now, I will do this method only. I won't go to the other methods. Let's continue here. So we all the substitutions and all is mentioned, and this is how we did it, and we did it a while ago. So that's the answer. But now let's see the next problem here. The same question, you can see the same question is asked again, But they are saying let's do it for x equals 1, 2, 3. Now if you're thinking about x equals 1 to 3, if you want to repeat this method again and again, it's going to be crazy, isn't it? You have to do this again and again and again. So how about they've asked, let's do it for unspecified value of x, so that we will get an answer, and then we will just substitute the x values and we will get the answers. So now what they're saying is, let's do it for unspecified value of x. So x equals a, instead of a we put x now, and now simplify this. Let's use the power rule and everything. Now instead of x over here, we put x plus h. Just a while ago I done using 1 plus h, the same thing, the vague method. I don't think so I can go back to, okay, this is the same thing here. Whatever we did, instead of 1 now we have x. That's the thing. Okay, now over here it's going to be different. It'll be x, h and everything. So let's see this now. Here what we are doing is the cube rule. It'll be a cube, that is x cube plus h cube, it's written at the end, 3 times x squared h and plus 3 times x h squared. And over here it'll be 2x plus 2h. It's just distributive property, multiplied inside, and then minus 1. And over here we have minus 3x cubed minus 2x plus 1. Why is this? Because x remains x itself. So write the same function. F of x is just this, divided by h. And now we simplified further, multiplying all this inside and simplifying what we can. All the numbers go off. It'll become, the numbers cancel. I believe last time also we got the numbers cancel. It's just plus 1 and minus 1. So the constants, I mean numbers in the sense, constants are 0. So all the things are just multiplied inside, simplified. And now over here you can see what has happened. You have x and h. Okay, so here you have to apply the limit. Now there is, it's, see, the h is removed common out from all h. The h is removed common out and cancelled with this. So you're remaining with 9x squared, 9xh, because h squared, h is gone, and 3h squared plus 2. Now there is no denominator, it's all in the numerator, so you can easily apply the h value equals 0 to this and solve. So over here h is approaching 0, so apply everywhere 0 and you will get only 2 terms, 9x squared and 2. So the derivative using this formula would be 9x squared plus 2. Okay, we found 9x squared plus 2. Now what do we want? We wanted 1. Okay, instead of, in this term, instead of x we have to just put 1 squared plus 2. If you want 2, we have to just put 9, 2 squared. Instead of x we put 2, and similarly 9, 3 squared plus 2. We can solve this all. Now it'll be over here, sorry. Okay, now it's fine. It'll be 9 times 1 squared is 1, 9 plus 1 is 11, 2 squared is 4, 4 times 9 is 36, 36 plus 2 is 38, 3 squared is 9, 9 times 9 is 81, 81 plus 2 is 83. So these are the answers. You can see 11, 38 and 83. So this is how we can solve considering x, and then we can just change these x values to whichever number we want. So we can find the derivative at x equals 1 or 2 or 3. So this is how we can easily solve it. So get an unspecified value of x and then change the variables x value to whatever is required. Now, just now what we did is basically derivative. We just learned about it. I'm sorry, this is not velocity, it should be derivatives. I apologize for that. It's derivative. Now here, this is the same formula. Now instead of getting as numbers as we did in the first problem here, instead of using numbers, we can always specify it as x. Okay, and that would be derivative, and the process of finding derivative is called differentiation. Okay, and we will see about this in a while, more in a while. But now here we have got this. Okay, one more thing. The simplified form, this f dash of x means you're finding the derivative, the process of finding its derivative, which is also called as differentiation. Okay, f dash of x means differentiation. Now they have told over here, find f dash of x for this 1 by x. We have to just use the formula, but instead of this x, what do we do? We have to put the instead of a value, we are putting x value and now solving it. So we will have to substitute instead of x over here, x plus h. So let me do this. Here what happens? Function of x plus h means it'll be 1 by x plus h minus f of x is the same function 1 by x all divided by h. Now we need to take the LCM over here. Let's take x times x plus h. That would be x minus x plus h divided by h. This is just algebraic simplifications. Over here you will get x minus x plus h divided by x squared plus xh, okay, divided by h. So now I can take this up, isn't it? This is denominator over here, the entire denominator, so we can bring this h up. So this and this cancels. We are remaining with h divided by x squared plus xh, and what's there? H is there. This cancels off. This is gone. What are you remaining with? 1 by x squared plus xh. Now what is the limit? Limit h tends to 0. When this is 0, you're remaining with only 1 by x squared. So that is the answer. 1. Okay, I have forgotten something. That is the sign. Let me just double check this. Okay, see, look at me. I've done a very, very important mistake. Now please don't do the mistake which I did. I have minus x plus h. Oh god, I should have remembered 1 by x derivative is negative 1 by x squared. You have to by heart these formulas in the next coming lessons. But you know, I was so drawn into the problem and I just didn't realize the mistake. I'll tell what was my mistake. Here it's minus 1 by x, and when we take the LCM here, multiply these two, x times x plus h, this goes over here, x minus x plus h. This minus will be multiplied, distributed to both the terms. It will be minus x and minus h over here. And so there will be minus sign all throughout. So you're remaining with minus h and h cancels. You're remaining with minus, and lastly it's minus 1 by x squared. This is the answer. Okay, so this is how you substitute and solve. Very straightforward, just substituting and simplifying it. Now you can write this over here. We know it's negative, that will be there. You can take this x up, but the power changes. You have to add negative sign. Now if you're taking this down, it will be 1 divided by, the sign changes to positive. If it was positive here, it would have been negative, negative, positive. It changes, that's it. Now same thing can be done for this. Please do try this by yourselves. Pause the video and try it by yourselves, just like what we have done a while ago. The formula over here, just that you need to substitute this over here. Let's try this anyways. But since we are dealing with square root, conjugates come in picture. Now let's do it. Here it'll be square root x plus h minus square root x divided by h. Okay. Now, what happens when you have square root? You can't simplify this without conjugate. What is conjugate? If you have square root and all, or you know, what is that? Imaginary numbers, conjugates come in picture. So basically, you have two terms, right? All you need to do is change the sign. It'll be square root a minus b. This is a conjugate of this. So in this case, just flip the sign. That's it. All the other terms remain as it is. You have to multiply and divide by its conjugate. Otherwise, you cannot simplify this. Now here, square root x plus h remains same. Square root x remains same. Up and down, it's the same thing. It's only the sign from negative, it becomes positive. Now, you know, there is a identity a minus b, a plus b. What happens? It'll be a squared minus b squared. So the same thing over here. The top term is a, the same term, minus and plus, same term, same term. So what happens over here is it'll be x plus h whole square minus root x the whole square divided by, now h is multiple of root of x plus h plus square root x. Okay, this much. Now here the square root and root cancels off, so you're remaining with x plus h minus x divided by this term below, x into square root x plus h plus square root x. Okay, now what's it? Here x and x cancels, and this h and h cancels. So you know what happens when we cancel these two go off, right? So I'll just change it over here because I'm lazy to write it again. And now this h and h cancels. Okay, so that's what happened. And now you're remaining with 1 by square root x plus h plus square root x. Don't forget the limit is always there. I just don't write it every time, but you have to write it if you're writing and solving this problem. This is very important term. Okay, so now this is the thing. I'll apply the limit h of 0 because it's all plus. I know nothing, it's not going to be undefined, so it's going to be 1 divided by square root x plus 0 plus square root x. So basically you're going to get 1 by square root x plus square root x. So what's the answer? It's going to be 1 by 2 root x. So this is the answer, 1 by 2 root x. And that's the identity as well. Oh, now you can even change this. You know how much is 1 root x? It's x to the power half. Now you can take this x to the power half. It'll be up, it'll be negative. So that's the thing, but you can just leave it. 1 by 2 root x is more than enough. So this is how you solve this problem here, just by applying formula. Don't forget the conjugate. With the conjugate is you solve it. I've done the methods over here. You can just rewind in the video and check it out again if you want. Now then, before going any further, okay, there's one more thing. The domain, see, it's over here only greater than or equal to 0. So don't forget the derivative over here, on the other hand, must be greater than 0. Okay, it can't be equal to 0 because it's undefined at the bottom. So even though the function was defined as x is greater than or equal to 0, remember, you must remember the domain might change. Why? Because here you have square root x. Yes, what's the domain for any square root function? It must be greater than or equal to 0. Yes, but now since it's in the denominator, you know there is another important rule. Whatever is in the denominator must be greater than 0. So this is, yes, true, but this is much more important because only with this you can't, because if it's 0 over here, it's undefined. So remember, the domain over here is greater than 0, not equal to 0. That's about the domain. Now we will see interesting problems about graphs and the possible graphing of derivatives. So there is a relationship between the graphs of function and its derivative. We will learn about this again in the next lessons, but now if I have a function like this, now it's let me just quickly skip this. I will be explaining this over here. Now let's look at this. It's a bit more zoomed, Now this is the given graph f. This is the figure. Now we need to sketch the plausible f dash. That's the derivative function. Now you have to know there are few things. Whenever there is change in the given function, in the sense it's changing from one direction to another, what is the derivative at this changing point over here? I mean, what's the tangent line look like? Derivative is the tangent itself, right? So how does the derivative of the tangent look like? If you look closely over here, it'll be something like this. Here it'll be like this. As it goes, it gets steeper. And when you reach this point, it'll be a flat line, isn't it? So the derivative would be 0 at these 2 points. Remember, wherever it changes from one to another like this, where there is a change, there the derivative would be 0. So whatever is your derivative would be passing through these 2 lines. I'll just show you the answer. Look at these. minus 2 and plus 2. It will be passing through those 2 points. But now anyways, we saw. So how do you know this is up and this is down and it's a quadratic? How do we know that? So how do we know is we need to see what's happening left of these two changing points, right, even over here, left and right. So you can see at left it is decreasing, right? It's decreasing. So here I'll just show this answer because it's much easier to understand from this. See, from this point, let me change the color. Oh. From this point exactly, it is decreasing. So you must remember this thing. Whenever it's decreasing, the function is decreasing, oh sorry, it's not decreasing, it's increasing. As you can see from left to right, I'm sorry, it's always seen from the left side to right side. It's not decreasing. Decreasing is something like this. This is a negative slope, downside, whereas like this or like this, it's always increasing. You look at this from left side, it's increasing here. See, it's all increasing. So whenever a function is increasing, the derivative will be at the positive side. So all before this, until this point, it'll be upside positive. Whereas over here it is decreasing, it will be down, negative. And again it's increasing, here it's positive. So that's it. So you know the derivative will be passing through these 2 points, and here it will be upside, and here also it must be up, and over here it's down. So this is the only possible graph you can see the derivative. So now let me just remove this and let me do it with from scratch, sorry. Now here are the changing points, these 2 points, okay? You must know these 2 points would be where the derivative graph passes. Next thing, what is happening left of this graph? Is it increasing or decreasing? It is increasing, so the graph will be plus over here. Here it's decreasing until over here it's decreasing, minus. Now if it was decreasing again, it would be minus only over here, so it will be something like this, the graph. We are not doing the accurate graph, we are just getting a picture about the graph, okay? So you can see there will be turning points, so there will be a change in the position, so it's minus. And what's happening from this point, turning point, it's increasing, so plus. So wherever there is plus from this point, just make it up, and here it's minus. That's it. So this is the answer of the graph. Now if it was the other way around, if this was given, also you can trace back to the original function, which we'll do in the next graph. So this is the answer. We are not looking for the exact answer. See over here they are telling not the exact values, it's just the shape or the idea of the graph. That's it. So this is for your understanding. And then the next one is to sketching the graph of f, the function from given the derivative. So again, now this is the answers, but let's see in the zoomed up version. So here we are. Now what do we have is the we have the derivative and we need to find the function. Here, okay, it gets confusing a bit. If you're thorough in one, then this might be translated. So let's work backwards now. Over there, you know, whatever was the turning point was very important because the derivative zeros were there. Now we have the derivative, so the zeros are very important, all the zeros, okay? All the zeros are important. Why? Because there will be turning points. It will be either over here like this, up or down, I'm not sure. So like that, there will be turning points. But now, before we see up or down, let's find out where it is. Now here, if it is down, it's down, negative, that would mean it was decreasing. All the left side is decreasing. It's either like this, right? It can be only like this. It should be decreasing. So you can see it is decreasing. Okay, now, sorry for that. Okay, it's decreasing. But let's do the same thing at the right side here. You can see it's plus. That means it'll be increasing. It'll go upwards. But now one thing, it doesn't touch these 2 points. This is just for reference. It'll go somewhere down because in the last case we saw the turning points will be somewhere over here. It can be like this, the turning points. So the same thing over here. The turning points will be somewhere down. It won't touch this point. This is only the derivative would touch this points, but here there'll be turn. The function turns, that's why the derivative is 0. Now, one more thing is, here it is increase, it's positive, right? That means it increases. And whenever there is a y-intercept in the derivative function, y-intercept of derivative will be always 0 of the function. At the 0, when the function is 0, the derivative will be at y-intercept. So this is the thing. So over here, let's trace back. We know there will be a turning point whenever the derivative is 0, because the derivative graph is given, that's the pink one. So we know there is a turning point. Left side it is negative, so it was decreasing. If it's decreasing, it has to come from up to down. And then here it's positive, that means it will increase, turns, it's a turning point. And until where? It will go up until over here, the next point. Now, here there is a turning point, but what is happening? You can see it's minus again, so that means it will come down until this turning point. Until this turning point will come down, and then last one is increasing. So it's like a W. It's not exactly this graph, but this is somewhat similar. Let's see the answer. Okay, you can see it's very, very bad, but still that's the answer, you know, because you're not dealing with exact values. Over here it has come 2 up. Okay, I did a bit down. So but this is the, you know, basic understanding about it. You won't know the exact values, but you will be able to, you know, draw a rough sketch of the graphs. So one of it is what I personally feel is, whenever you have been given the function to find the derivative, the first problem 2.5, that is very easy. This gets confusing at times, you know. I personally get confused at times, so I need to, you know, rework that. And you know, I was a bit rusty now, so that's the thing. But anyways, with practice you will be able to easily find the correct graphs. So this is the answer. And even over here they are mentioned, don't worry about the exact values. It's just about understanding these few points which I mentioned, and then easily get the graph. Now then we will go to the next one. Before that, alternative derivative notations. So over here we have Gottfried Leibniz. So Gottfried Leibniz, as we always call him as Leibniz notations. He was a German scientist, and he was very, very brilliant person, brilliant scientist. He was a mathematician, philosopher, everything. And he also found derivatives, calculus on his own. He didn't, take the idea from Isaac Newton or something. Isaac Newton was, widely known to, invent the calculus. But Leibniz, on his own as well, found the calculus, and he used different notations called d by df, like this. Okay, delta, like this, used to write. And those notations are called Leibniz notation. Now, sorry, df and dx. These notations are generally called Leibniz notations. And there was a clash between those both, because I remember reading a book by Stephen Hawking, and he had written something about both of them, because there was a lot of problems with Newton and Leibniz, because Newton wanted to take all the credit for himself, but it was Leibniz had done it by himself. But now it's widely known and accepted, and both are being given the credit, Leibniz and Newton as well. So he didn't copy it from anyone, he did it by himself as well. So that's the thing. This is just a simple thing about Leibniz notation, and I just wanted to stress on that. Leibniz is a famous scientist, and he has done a lot of work, especially in engineering and other fields as well. You will have to read about him. You can read about him. Okay, now the thing is, y dash is just dy by dx. Okay, this is by Leibniz. So this is interchangeable. So if you see y dash, derivative would be like this, d by dx. Okay, d by dx of any function f of x. Okay, function f of x is y, so you can write dy by dx. So this is just another way to write it. There's no problem. We'll see some problems now. And one more thing, if f is differentiable at x equals a, then obviously it must be continuous. So wherever it's not continuous, you can't differentiate it. We will see problems on that as well. Now over here we are. So this is a piecewise equation. We have two functions here. Let's graph this. Now imagine this, the graph x is 2 over here. This is the point in which we are dealing with, x at x equals 2. So whenever x value is less than 2, it is 4. It's a constant line. So imagine this is 4, it's a constant line. But then when it's greater, you can see it's straight going upwards. So you can see there's a sharp corner. So whenever there's a sharp corner, there is no differential, there's no tangents. You can't draw a tangent to a sharp corner. It should be a curve only, right? So that means there is no difference, there is no derivative, it's not continuous, I mean, it's not continuous. So that means you can't differentiate this as well. Let's see now. You can use say this is the graph over here, and let's use the formulas. So this is the formula. First, let's start at the right side of 2. Right side of 2 means positive of 2. That would be 2.01 and so on. That's this function. Okay, it's 2x, this one. So here, instead of x, you need to put 2 plus h. So it will be 2 of 2 plus h minus function of 2. Instead of x, it's 2. 2 times 2 is 4. So you're just substituting over here. Say this, how to solve this? This is the function. It will be 2 of 2 plus h minus 2 into 2 divided by h. Let's substitute, let's solve. 2 times 2 is 4 plus 2h minus 4. This cancels out. You're remaining with 2h by h. The answer is 2. So the answer over here is straightforward, 2. Now it's not over. The same thing must be continued for what? 4, this one, at less than 2, right? So let's do this. Here it will be the same function, but is there any x over here? It's a constant. So it is basically 4 minus 4 divided by h. Answer is 0. Can you see? Because there is no x, so you can't substitute these anyway. It's just the constant 4. This first term just becomes 4 minus, even the second term is 4 divided by h, which is basically 4 minus 4, 0. 0 divided by any number will be 0. So it's just 0 over here, okay? If you go from the left side, so basically this h is not 0, so it won't be undefined. It's something that's left of it, so there'll be some value. So here you can see both the values are not same, so limit does not exist, right? Limit are not the same. They do not agree and do not exist. So what we can say is it's not differentiable. That's it. That's the concept behind this problem. And okay, where do derivatives do not exist? Where, or which all cases? So they are basically a jump discontinuity over here at vertical asymptotes. A cusp is something which is formed like this, like a sharp corner only, okay? Corner is also something like this. This is a cusp and vertical tangent line. So these are all the places where the derivative does not exist. If you have these graphs, the derivative does not exist because these are not continuous. And you can just, if you know the graph and you know it's something like this, you can just tell derivative does not exist. This is about it. And now, approximating a derivative numerically. Now we have solved the formula so many times now. Why do you need to do it numerically? Now look at this function here. Try applying the formula. Pause the video and try it by yourselves. Try at least for like 2 minutes and then you can watch it back. I hope you tried. You'll realize it's a crazy thing to do, use this problem using formula, because it is very complicated. Why is it complicated? Because over here, if you're doing that x plus h, just substitute x plus h the whole square root of x plus h the whole cube plus 2. It's going to be too long and you have to just find that x equals 1. So you can do it using the formula. It's going to just take a long time. So how about you use the method which we have done in the previous lessons and the previous chapter as well. So instead of all that, at x is equal 1 plus h and f of 1 minus, you can do this over here, substitute instead of x put 1 plus h the whole square, here also 1 plus h the whole cube, and here it will be 1 and 1, and solve it, or directly use the values. Okay, so we are taking values corresponding towards 0, and then you're directly getting the answer. So now, oh, one thing you might be wondering, why are we taking this? So here h value always approaches 0. Now don't think it is 1, x is 1, so shouldn't I take 0.99 and 1.01? No, x is 1, so in the formula what happens? This a value is 1, but this limit of h always approaches 0, isn't it? Limit of h. So remember, this over here column is for h, so you must always consider the values close to 0. So it'll be 0, 0.01, that's negative, and 0.01, that's positive. So and then substitute and solve. You can try this, just substitute the basic things and then directly put in the calculator, you will get this answer. So that is the thing. And you know, such problems, finding the derivative, we will do it now, you know, because substitution takes a long time. I'll tell you another shortcut, which we will in the future lessons. Now you can see your calculator that d by dx is there, right? So this is derivative. We saw just now a while ago Leibniz notations. Now if you want to find derivative of this function, you have to just substitute this alpha x squared, multiply it with square root alpha x cube, cube plus 2. At what? At x equals 1. Let's check the answer. It should be 4.33. Yes, that's the correct answer. So this is one other way. We will do all this direct derivative and the formula derivative in the next lessons, in the same chapter in the next lessons. So just to make clear, this h approaches 0, so therefore it's 0.001. It's not x equals 1, not this x value over here. X value will be substituted in the formula instead of a. This is how you can easily solve it using numerical approximation, numerical method. And last one over here, we are estimating velocity numerically. Now let's read the problem. Suppose that a sprinter reaches the following distances in given times. Estimate the velocity of a sprinter at 6-second mark. Okay, we are supposed to estimate at this mark. Now over here we have seen in the previous lesson that this distance, the time interval, must be as narrow as possible. You can see there is 0.5 seconds over here, whereas over here it's 0.1 seconds. This is more accurate than the others, isn't it? Instantaneous. As we narrow it down, we get the most accurate results. Now since they have told 6-second mark, which is the most ideal to take? Is it from 6 to 5 or 6 over here, or the nearest one? This is the nearest one. So we will take from here to here these two, and you can just find the average. We have done this already, so that's the thing. Okay, over here from 5.9 to 6 and 6 to 6.1. Now it's not over here. I just realized there are tables which I didn't put. Now we will just do the table. So now over here, now I just put the tables and I'm back again. So here are the tables. Now I'll just go through this because otherwise it will just take a long time. Now since over here we are dealing with 5.9 and 6 and 6 to 6.1. How to find the average velocity? We have done this previously. It is the function f of x values. It's 158.4 minus 154.9. It's higher minus lower divided by the difference. 6 minus 5.9 is 0.1, but I'll just write it over here. So this is the answer. It's 35. You can see during the time interval over here, it's 35. Now what about the others? The same thing over here. It'll be from 161.92 minus 158.4 divided by 0.1 gives us 35.2. And you can do it for all the intervals from 6 to 5.5, 5.8 and so on. See, it's just that we have done for all the other terms. I'm not going to do it again and again. It's the same method what I use. So if you're using these two over here, this and this, it'd be 158.4 minus 123.7 divided by 6 minus 5. Then you'll get the answer over here. So it's estimated for all the intervals because we need the six mark. And now you can see, compare and tell. It's safe to say it is, around 35. Now, what you can do for more better is, this is 35, this is 35.2. Just take the average of these both. So we could, between these both, it'll be 35 plus 35.2 divided by 2. That would give us 35.1. So that would be the answer. That's the thing. Over here, it's just corresponding to the same thing. Anyways, it's not a proper. It's just to understand you. Just give you understanding. What has been done. So this is how we can estimate the velocity, and these velocity problems we have already done in the previous lesson. So that's it for this lesson. It's a bit lengthy, and there are plenty of different type of topics. There were so many objectives. In the sense, they were all different types of topics, but each one are connected in a different way. As you can see, it's with derivatives, differentiation, all of them have linked to each other. In the next lessons, it gets much easier, and once you study the next lessons, you can come back to these lessons and solve them very, very quickly, very simply, without the formula, without the huge formula and calculation. You can just remember few of the formulas and directly solve it. So please do stay tuned for the coming lessons, and if you have any doubts, please do post them in the comment section. I'll try to get back as soon as possible. Happy learning, and see you in the next video. Bye bye.